Okay, we're going to start with some review problems. We're going to begin doing some of these identities, simplifying these identity problems. We will be referring to our worksheet here for these basic identities. Actually, these 6 and these here, these new ones, right? Tangent is sine over cosine. Okay, so let me have you understand this. The review here, so that you understand exactly what's going on, is as simple as this. Let's say number 1. If I have 3 over 5 times 5 over 2, right? Well, on the top, remember, we don't want to multiply this. We don't want to get these big numbers, so I know it's 3 times 5 on the top, 5 times 2 in the denominator. And then you know that you look to simplify if seeing something can reduce. Well, with numbers, we know the 5 divides out. 5 divided by 5, it's a 1. It cancels out. You can put a 1 and a 1 if you want. And that's it. That's something has to eliminate or simplify. And then you're going to get what? Well, the answer is 3 over 2. It's easy for numbers. It's the same thing you're doing it here, but we got to take it from here to these identities. But essentially, this is the math that's going on. You're going to start off with a multiplication problem, but easily they could have set this one up as 3 over 5 divided by 5 over 2, and then you know how it changes to times, and then you flip it. But eventually you get your problem to this point where it's a multiplication. Okay, let's try another one. So, what if you have 8 times 7 over 8? Well, again, I want to see a fraction multiplying a fraction. So that's 8 over 1 times 7 over 8. Remember, you don't have to do the reciprocal. It's already a multiplication. And then you look to reduce. Well, we can see that the 8s, again, they divide out. You're left with 7 over 1. The answer is 7. All right. Simple, right? This is exactly what's going to happen, but with the identities. What if you have 1 over 4 times 4? 1 over 4 times 4, well, that's the same as 1 over 4 times what? 4 over 1. Remember, always you want to see fractions times fraction. Or if it's division, well, it's division, but then you eventually get it to this point. And then here, we look to reduce. Anything from the bottom or the denominator can reduce with anything from the numerator? Yes. And this turns to what? 4 divided by 4 is 1 and 1. They don't cancel out and the answer is 0. You get what? 1 over 1. 1 over 1, right? 1 times 1, 1. 1 times 1 is 1. Well, 1 is the answer. Okay, remember, this is review. Okay, and now let's take it away from numbers. All right, let's take it away from numbers. What do you have? 2 over x times x over 3. Isn't it the same scenario? Again, I mean, yes, there's numbers here, but what's happening here? On the top, in the numerator, 2 times x. On the bottom, x times 3 or 3 times x. However you want to write it is fine. I'll put 3 times x. I mean, it doesn't matter, right? Because what's going to happen to these x's? See, if you see something in the numerator that matches with something in the denominator when you're in multiplication, you can divide them out. See? So here it wasn't numbers that divided out, it was a variable. And you're left with 2 over 3. Okay, one more of these review simple ones, and then you'll start seeing the ones with the identities. What if I have cosine over 1 times 1 over cosine? Well, this is really going to be cosine over what? Cosine. Just like if it was 2 divided by 2, just like if it was x divided by x, cosine divided by cosine, right? They match, they cancel out. You get 1 over 1. The answer is 1. Okay, so the concept is the same. It's the same as these. Eventually you'll get your problem to multiplying fractions, and then things will match something from the top and the bottom, and then they'll simplify that way. All right, let's try some really simple ones with the identities. Okay, now for these, right, it's going to say simplify. Here's the hint. Here's the hint, and I'm sure I will go over it in class. Simplify or evaluate. The hint is this. You always want to always work in sine or cosine. We always want to work with sine or cosine. Okay, so we know sine. We already know sine and cosine. We'll leave that alone. And if I see a sine, I leave it. If I see a cosine, I leave it. But if it's a tangent, remember our new formula, our new ratio for tangent is what? See, even tangent is with a sine and cosine. This is the one you want to use. And if you see cotangent, you can also change it to cosine over sine. So tangent is what? Sine over cosine. So you want to work with sine. If it's sine, leave it. If it's cosine, leave it. If it's tangent, change it to something with sine over cosine. But then what if it's cosecant? What if I see something that's a cosecant? Well, remember these reciprocal identities over here? If I see a cosecant, you don't want to use cosecant, you don't want to see secants, you don't want to see cotangents. And if you see a tangent, you don't want to see that either. You change it to something with sine over cosine. If I see a cosecant, I'm going to change that to what? I have to change it to what? Something with a sine or cosine. Well, I know cosecant is 1 over sine. So if it's sine, you're going to use sine. Let's just leave it. If it's cosine, you're going to leave it as cosine. If it's tangent, you're going to change it to what? Sine over cosine. Somehow, some way, each of these can lead to a sine or with a cosine. If I see a cosecant, I'm going to change it to what? 1 over sine. If I see a secant, right, from our identities here, I'm going to change it to 1 over cosine. I always want to work in what? Sine and cosine. Right? Hint. Always work or convert or change everything to what? Sine or cosine. So remember the first three, SOHCAHTOA, sine, cosine, tangent. The first two are already sine and cosine, leave them. And then if we see a tangent, it's sine over cosine. And then if you see a cosecant, well, we know cosecant is, this is the identity for cosecant is 1 over sine. Secant, right? You know cosine and secant go the same, but secant, you're going to change it to what? 1 over cosine. Tangent, you're going to, how about cotangent? You're not going to put 1 over tangent. Remember, if tangent now we're accepting as sine over cosine, that means that cotangent would be what? Remember, reciprocal? Cosine over sine. So from these first three again, sine is already in sine, always work in sine and cosine. Sine is already a sine, cosine is already a cosine. Tangent, we're now accepting as sine over cosine. So I got these three with a sine or a cosine. And then these other new three, right? The cosecant, secant, the cotangent. Well, this is 1 over sine. This one I changed to 1 over cosine. And then again, since remember, we know tangent is sine over cosine, the reciprocal is for cotangent, cosine over sine. So somehow, some way, any of these 6 I can refer them back to either a sine or a cosine. All right, so let's look at that and how you're going to simplify this. Here we go. And you have your, right, we're looking at all these here. They're either reciprocal or the tangent ratios, the ratio, the tangent, or the cotangent. Okay. So let's look at number one. You can have a problem something like sine times cosecant. Now sometimes they won't even show the little dot. They'll just put them right next to each other, right? Just like 5 times x, 5x. They're not going to put 5 dot x. They'll just write 5x. Here they'll just write sine cosecant. You'll see them together like this. Well, you know that it's multiplication. Okay, so I know this is sine times. I'm going to leave a little space just to see them separate. So, is this a sine or a cosine already? Yes. So this is going to be sine over 1. Remember, leave it. If it's already a sine, leave it in sine. And cosecant, what can I change cosecant to so that it has a sine or a cosine? Well, I know cosecant is what? 1 over sine. And here we go. Now we're looking at this part where I tell you that you're eventually going to be left with a fraction times a fraction. Sine times 1 is sine over what? Sine, right? Or you can just see here that they cancel. The answer is 1. So your job is to get these identities. If it's already a sine or a cosine, leave it. If it's not a sine or a cosine, you got to use one of these identities and change it. See, so in this one, we change the cosecant to what? 1 over sine. All right, let's look at number 2. Tangent cosine. What does tangent cosine together mean? It means tangent times the tangent ratio times cosine. Now I'm going to first ask myself, are any of these already a sine or a cosine? Yes, here's already a sine or a cosine. So this is already cosine over 1. I'm not going to change this to secant. I want to work only in, right? Everything eventually here will simplify with only a sine or a cosine. And tangent, you're not going to write as 1 over cotangent. It is true that tangent is 1 over cotangent, but now for these identities, what do I know with tangent that has a sine and a cosine? Tangent is what? Sine over what? Cosine. This one we left it, it was already a cosine. This one we changed tangent to what? Sine over cosine. And now you just simplify and you reduce and you do this. Well, I got sine times cosine over cosine. What happens here? Right, these can cancel, right? Sine times cosine over what? Cosine. Well, the cosines divide out, they cancel out. What's your final answer? What's left over? Sine over 1? Sine over 1 is just sine, right? Okay, number 3. Tangent cosecant. What does it mean if you see like this? 2 functions together. It means they're being multiplied. This is a tangent times what? Cosecant. Are any of these sine and cosine? No, I got to change them both. I have to know how to change this to either a sine or a cosine. So looking at your identities, I know tangent is what? Well, you're not going to put 1 over cotangent. We don't want to use cotangent. We want sine or cosine. Well, tangent is, right, our new understanding for tangent is sine over cosine. Times, and And cosecant, what do I know about cosecant? Cosecant is what? 1 over sine, see? And we're getting back to the scenario, a fraction times a fraction. What happens here with sine over cosine times, well, something in the bottom can cancel with something on the top. You are left with what? The answer is 1 over cosine, right? The 1 is on the top, the cosine is on the bottom. This is acceptable, but I think the book is going to say the answer is, right? Because 1 over cosine is the same as what? 1 over cosine is the same as what? Secant. Right? From the identities. Remember, cosine by itself is just, cosine over 1 by itself is just cosine. But 1 over cosine, remember, we learned these identities. 1 over cosine is secant. Okay, number 4. Secant tangent? No. Secant cotangent. What does it mean that they're together like that? It means you're multiplying. You're multiplying a secant times a what? Times a cotangent. And the big hint, the big clue is to always work with sine and cosine. Are any of these sine and cosine? No. No. Secant though, secant I know is what? 1 over cosine times, and cotangent, I don't want to change cotangent to 1 over tangent. I don't want to work with tangents. I just want to work with sine and cosines. That's where we go to this one, see? Cotangent is what? Well, if tangent is sine over cosine, if tangent is sine over cosine, the reciprocal of tangent is cotangent. The reciprocal of sine over cosine is cosine over sine. So cotangent is cosine over sine. So again, now we got a fraction times a fraction. Does anything in the top match and can cancel with anything in the bottom? Yes, definitely. That's how these are set up to happen. The cosine divides out with the cosine. What is your answer? Not sine. Your answer is what? 1 over sine. Right? The 1's on top and the sine's in the denominator. 1 over sine. That's correct. But 1 over sine is equivalent to what? 1 over sine is what? Cosecant. Okay. A couple more. Number 5, sorry. 5. Cotangent theta times sine. Well, we use cotangent over here. Cotangent is what? Remember, if it's already a sine or cosine, leave it. Oh, there we go. I'm going to leave this already. Whew, that's good. I'll just leave it as sine over 1. Sorry, I don't have to change it. But this one, you are going to change it to what? Not 1 over tangent. Remember what's cotangent again? That has a cosine as sine. Cotangent is cosine over sine. And here you go. You got cosine over sine times a sine over 1. Anything in the top match with something in the bottom? Yeah, the signs cancel out. Here you're just going to get what? Cosine over 1. Cosine over 1 is just cosine. All right, last one. Tangent sine. That's going to be what? Tangent times sine. Well, sine is already, remember, I want to just work with sine and cosine. Tangent, sine is already sine over 1. Tangent, though, is the one you got to change. Well, what's our new form of tangent that includes sine and cosine? Tangent is what? Sine over cosine. Tangent is sine over cosine times what? Sine, I'm going to leave it right because I want to work with working only sines and cosines. Sine over 1. Here, nothing cancels. Here, nothing's going to cancel. A cosine doesn't cancel with anything. So when you get sine times sine, just like if you get x times x, it's x squared. Just like when you're multiplying x times x is x squared. Sine times sine, you put the square not on the angle, not up here like you're, because that'll mean you're squaring the angle measure. No, we're squaring the function. So this would be sine squared. The square goes right here, not on the angle. Sine squared over what, right? Sine times sine is sine squared over what? Cosine times 1 cosine. Well, just leave that there like that. Okay, we'll do a couple more on the next video.